Okay, so basically the first part is reviewing the completed square. This is how we're going to find the vertex. So we didn't quite grasp it. Pay attention. Go through the steps again. So y is equal to x squared plus 6x. Now we want to be adding something to that to make that a perfect square trinomial. So we leave a little space for that so we determine what it is. So what was a little formula, a little trick that we discovered that if here we got x squared, so it's a perfect square itself, right? How do we get that value here? What constant do we need to add on here to make the perfect square trinomial? Rob?
You divide 6x by 2 and then you square it.
Right, so we take this coefficient 6, right? So we want 6 divided by 2, we want to square it. So we get 3 squared, which is 9. Okay, so we want to add 9 to this, right? But at the same time, we just can't add 9, we have to subtract 9. So we keep our equation true. Yes, Adrian?
So when you take the coefficient, never take the sign in front of it.
Sorry?
When you take the coefficient, never take the sign with it, so it's like -6. When you take the sign with it?
Well, yeah, you take -6, but what happens when you square it though? You're always going to get a positive. So you can take the sign or not take the sign, right? The fact is, because you're always going to square it, it really doesn't matter. Okay? If you're a purist, you take the sign with it. Okay? So here we have our perfect square trinomial. And what that means is that we could rewrite that now as x plus 3. Notice that this 3 is the same as that, quantity squared. And we're still, this part is just the same. Not doing anything with that yet. If you want to do it on one step, that's fine. But I want to demonstrate just that first step by converting this part into your perfect square trinomial. So now we have y is equal to x plus 3 quantity squared. Well, minus 9 minus 16 simplifies to minus 25. So therefore, our vertex is -3 minus 25. Okay? Question, Kate?
To get the 3, you found the square root of 9.
No, we took that number, right? The 6. We just divided that by 2. So we did two things with that number once we divided by 2. Now this part, you have to take the sign, right? So if this was a -6, this would be a -3. But because this is a positive, that keeps the sign. Okay? And so we take that, but we needed to square it to get this number over here, to get the 9. So that we could convert or factor, if you like, the x squared plus 6x plus 9 and factor that to be x plus 3 quantity squared.
Oh, I see.
That was the whole idea of getting that 9, so that we could factor it so that it looks like a perfect square trinomial.
So the 3 is from the square root of 9.
You could look at it that way as well.
Oh.
Okay. Any other questions? Matt?
Since you don't have an a value, you don't have to multiply in the second step.
Exactly. Because we don't have any value in front of the brackets here. In fact, there's no brackets. We don't have to distribute anything, right? So it's very different from the warm-up or the question Adrian asked at the beginning where we had that -2, right? Once we had that, we had distributed it back in. Okay, once we factor it out, it seems weird. Once we factor it out, we have to distribute it back in. Okay? So the second part of the question is about the x-intercepts. How do we calculate that? So that was sort of like the question in the quiz as well. How do we know how to calculate the x-intercept, or the zeros, or the roots? What's the technique that we've learned to get those x-intercepts? It's our favorite F letter word. Well, actually, probably second favorite F letter word in math. First one is fractions. I know how you love fractions, right?
Is it factoring?
Well,
Factoring.
yeah, your second favorite F letter word in math is factor, right? So we want to factor this. So here's the second part of the question. Well, y is equal to So in order to factor this, since you guys are familiar, or mostly familiar with PSI,
I have PSY.
PSI,
I get it.
no, I don't want to do psi style.
Oh.
Right, what's the coefficient? So it's 1 times negative 16. So we want two numbers that multiply to negative 16 that add up to 6. So what two numbers add up to negative 16, sorry, multiply to negative 16 that adds to 6? Nicholas?
8 negative 2.
8, negative 2?
Yeah.
So 8 times negative 2 does give us negative 16, 8 plus negative 2 does give us 6. So taking those numbers, we want to factor by decomposition, right? So this is where all that stuff we learned in the last unit is coming back. We need to be able to apply these things now, okay? So if x squared, we're going to break up the 6x using these numbers here. So I'm going to do minus 2x plus 8x, and it's still minus 16, okay? So do my factor by decomposition. I want to group these two. So I get y is equal to, I'm going to factor on x. So x minus 2. And what is it that I want to factor out of this part? Sorry? Yeah, so I want to factor out 8. So I factor out positive 8. So I'll factor out positive, factor out positive 8, and I'm left with x minus 2. So now we have y is equal to, I'm going to factor out now the common binomial of x minus 2 out. We'll have x plus 8. Okay, yes, Katie?
Would we know do like the other two? Like, is it two different questions that you're asking us, or?
Well, yeah, it's two questions. One, I want you to get the vertex by completing the square. The one is, I just want you to get x-intercepts. So right now, the only way that you know how to get x-intercepts is by factoring, right? So once we factor it, it goes back to the video of Mr. Khan, right? What does x-intercepts imply? What's special about the x-intercepts?
You can find the axis of symmetry.
We can find the axis of symmetry, not quite yet. Not quite yet. But what's special about the x-intercepts? Audrey. We can eventually find the vertex, but we already know the vertex from the first one. But at the y, at x-intercept, what's the value of y?
0.
Value y is 0. Right? So because the value of y is 0, it's very special. And this is why we're factoring, is that when we have a bunch of numbers multiplied together and the result is 0, if any of those numbers is 0, our answer is 0. So, let me ask you this. What is this number times this number give me right, 3 times 69 times 0. 0. Okay? Idea is once we have a whole bunch of things multiplied together, if any one of those is 0, it doesn't matter what the other numbers are, it's equal to 0. So that was the whole idea of factoring. Just getting a bunch of things multiplied together so that if we want an answer of 0, we could just set any one of those equal to 0. So here we're just solving for two equations now. X minus 2 is equal to 0, or x plus 8 is equal to 0. So now we're solving for two linear equations, sorry, two small equations that we've done in grade 9. So here I want to add 2 to both sides. And we have x is equal to 2. Here I want to subtract 8 from both sides. And so x is equal to negative 8. Right? So when x is 2, what's my value of y? 0. So therefore the x-intercepts are well, when x is 2, we do have y is equal to 0. And what happens when x is negative 8? What happens when x is negative 8?
So y is 0.
Y is 0. So those are my two intercepts. Okay? And we took x equals 2, when we plug it back into original equation, we should get 0. So what's 2 squared? 4
Ouch.
plus 6 times 2, which is 12. So 4 plus 12 is 16 minus 16. Lo and behold, we got 0. Right? We do the same thing with negative 8. What's negative 8 squared? 64? Negative 8 times positive 6 gives us negative 48. So 64 minus 48 is 16 minus 16 gives us 0.
Lo and behold,
Okay? That's what that means. When we have those x-intercepts, when we have those values of x that make it 0. We could also call these the zeros or roots are 2 and negative 8. Okay? Talk about the same thing, just two ways to describe it. So we say zeros or roots, it's implied that we're looking at y is equal to 0, so we just want to say the x value. Okay? X-intercepts are actual points, so we want coordinates. So this is what I like about this one question is we just reviewed the quiz, essentially, right? How would I go off and graph this? I have my vertex, I have two other points, my x-intercepts. Boom, I could graph this, right? Even if you didn't know how to complete the square, what Audrey was talking about was that now we have our zeros, we can find our axis of symmetry, and we can find our vertex as well, which is what the whole video that we did in your self-study, self-review. Okay? So lots of different techniques, which you want to choose to go ahead, right? So now I give you another way to calculate the vertex, which might be faster than figuring out the axis of symmetry, plug in that in, figure out my y value. Okay? Questions? So now I'm going to do something funky, if I could do this.
Move it down first.
It's okay, let me do this. So we're working with that same equation.
oh no, you didn't.
And we know that y, this could be re-expressed as y is equal to x plus 3 quantity squared minus 25. Okay? Right? That's what we did to complete the square. It's the same equation. Same thing. So now I'm going to answer that question of how do we get the x-intercepts a little bit differently. What do we know about when the x-intercepts were special again?
Y equals 0.
Sorry, say that again nice and loud, Adrian.
Y equals 0.
Y is equal to 0, right? Oops, sorry. So y is equal to 0. Is equal to x plus 3, 20 squared minus 25. So now we have a quadratic equation we want to solve for, right? What values of x will make this 0? How can I solve for this? Well, we put it at negative 3. Negative 3 plus 3 does give us 0, but now we subtract minus 25, so the answer is minus 25. So good try. You're looking for that 0, But because we have the negative 25 here, it doesn't really give us an answer of 0. It just gives us that this part is 0. Okay? So let me ask you this. If the question was 0 is equal to y minus 25, how would you solve for y?
Negative
Sorry,
25.
Sorry, too many answers. Hands.
Just go.
Marcus?
You put it in positive 25?
What am I really doing? Not flipping. I didn't teach my grade 9. Don't flip. We don't move things because math's not about magic.
You subtract from one side.
I'm adding 25 to both sides, right? So I'm adding 25 over here,
Vanish right here.
right? We could do things to one side, so essentially I'm adding 25 to y minus 25, just have to do it to the other. So really, y is equal to 25. Take that shortcut, most of you know that shortcut, right? You just go y is equal to minus 25. But that's the mathematical truth underneath the covers. We're not moving anything, we're not flipping anything, we're doing something to both sides. Yes, Mo?
So what if you made, I don't know if this is gonna work, if you made x negative 8, because then you could do negative 8 plus 3 would be 5, and then 5 squared is 25, 25 minus
So you see, you just figure out in your head, right? So it's good, you're right. I'm going to show you a mathematical way you can do this, right? But you're right, negative 8 is one of the answers, okay? So we saw that when we added 25. So we're going to do the same thing here. We're going to isolate for the squared part, right? We talk about isolation, right? Getting it by itself. So we're just going to add 25 to both sides here. So we got 25 is equal to x plus 3 minus squared, right? So you want to isolate for the part that's being squared. Now how do I undo that square? What's the opposite of squaring something? Square root. So you guys all familiar with square roots? So now I want to take the square root of both sides. Right? So the whole purpose of taking a square root was so that I'm left with x plus 3 over here. What's the square root of 25? 5. Is that the only answer for the square root of 25? In other words, is 5 the only number that you can multiply by itself to get 25?
Yes.
How many say yes?
Oh, negative.
Oh, right.
Thank you, Demetrius. So 5 is not the only number that you can multiply by itself to get 25. Negative 5, we multiply by itself, also give us 25. So how we say this is that really our answer is plus or minus 5, right? We get plus 5 will give us, no, square will give us 25, negative 5 squared will give us 25. So the answer is plus or minus 5. So now we want to isolate for x. Well, what do we do to this side to isolate for x?
Minus 3.
Yeah, so we subtract 3, right? So we need to subtract 3 on this side. So negative 3, so x is equal to negative 3 plus or minus 5. So really x is equal to minus 3 plus 5, or x is equal to negative 3
Oh, those both do it.
minus 5.
That's tricky if it is. That's very tricky.
So here I'm solving for our two equations again. So x here is x equals to 2, and here x is equal to negative 8. Is that not the same answer that we got over here?
Oh,
Right? So another way that we could kind of do this. Oh, I didn't want to do that. Right? So there's another way, because the whole thing is that we're solving for when y is equal to 0. We're doing that both times. Right? When we had it in factored form, we're solving for y is equal to 0. Here, when we had it in complete to square, we're just solving for y is equal to 0. Okay, any questions on that? So a couple of different techniques of solving for an equation. Which one is better? Which one is worse? I don't know, it's up to you. There are different things though that we could do. So here, I want you to find the roots of the following equation. So given that I only have 8 minutes left, we're just going to go through it together. So now we have an equation. How can we solve for x? We have a quadratic equation. How can I solve for x? Okay?
I'm just thinking back to it. I'm thinking what we just did before, so divided by 2. Divide the negative 12 by 2, sorry.
Divide the negative 2 by 12. Okay.
Negative 12 by 2.
Negative 12 by 2.
And then square that number.
Okay.
And then never mind.
Well, no, you're on the right track. So what are you doing? What's that process that you call, what's that called? Complete the,
Square.
complete the square. So you're saying on this side, on the left side of the equal sign, we want to try and complete the square. So we could try that. Yes, Marcus?
So if you make the 27 a positive to the other side, couldn't we put a 0 on the other side? Wait,
So we'll have a couple of techniques. So we're going to try to explore that. Okay? So first I'm going to take what Dan is saying. So Dan is saying, well, on this side, we're going to try to complete the square. Okay? So the process again, can you say again, Dan? So what is it we want to do?
Divide negative 12 by 2.
Okay.
Square that number.
So what did we get?
So 636.
So we got negative 6, and then you want to square it. So we got plus 36. Can we arbitrarily add 36 to our equation? No, what we do to the left side, we must do to the right side. So here, well, the whole purpose of adding 36 was so that we could factor our equation to make it look like a perfect square trinomial. X minus 6 quantity squared is equal to, and what's the right side simplify to? What's the right side simplify to? 9. So now I want to solve for x. Take the square root of both sides. And then I would say, well, this is now x minus 6 is equal to 3. Yes? Square root of 9 is 3? Yes, not 3. It is not 3, it is positive or negative 3. Right? I think I disagreed before. So it's plus or minus 3. Now we want to isolate for x. So how do we isolate for x? What do we need to do?
Bring the negative 6.
Well,
Add 6 to the left side and then add it to the right side.
so we're going to add 6 to both sides. So we add 6 to the left side, we get rid of the negative 6. So we have 6 plus or minus 3. So now we're solving for two equations. X is equal to 6 plus 3, or x is equal to 6 minus 3. So here x is equal to 9, and here x is equal to 3. So therefore our roots are 9 and 3. Oops, not 9 comma 3. 9 and 3. Right? And we see if we plug in our initial equation back into here, well, what's 9 squared? 81 minus 12 times 9 is 108. So 91 minus 108 gives us negative 27. Good. 3. What's 3 squared? 9 minus 3 times 12 is 36. So 9 minus 36 is minus 27. Right? So those are the two values of x that will solve for this equation, will make this equation true. Yes, Adrian?
So what if it doesn't work out that you can square root 9? Like we square. What if 9 was not?
We'll get to there. Good question, we'll get to there. Right? I want to follow on what Marcus was talking about. Right? So another way we could kind of do this was, well, Marcus said from the beginning, what happens if I add 27 to both sides? So we get x squared minus 12x plus 27 is equal to 0. well, we have something that's equal to 0, maybe we could try to factor this. So my product here is 27. 1 times 27 is 27. My sum is 12. So what two numbers multiplied to 27 add up to 12? Demetrius? Positive 12. Sorry, negative 12. You're right, it's a negative here, so negative 12. So what two numbers multiplied to 27 add up to negative 12?
Negative 3 and negative 9.
Okay, so negative 3, negative 9. So we factor this, we have x squared minus, no, that's not what I'm doing.
How do you do?
Erase this. So x squared minus 3x minus 9x plus 27 is equal to 0. Factor out x, so I get x minus 3. Factor out a negative 9, so I get x minus 3 is equal to 0. So I have x minus 3, x minus 9 is equal to 0. Again, we want each of these to be equal to 0. So I'm solving for two equations. Oops. Jump the gun.
Wait, why?
X minus 3 is equal to 0. X minus 9 is equal to 0. So therefore x is equal to 3. X is equal to 9. Got the same answer. Two different ways to get at the same answer. Yes, Cecina.
Why did you get x minus 9 when it's negative 9 bracket x minus 3?
Right here? How do I get x minus 9 here?
Yeah.
Well, when I factored out an x minus 3 here, what am I left with?
X. Oh.
X, right? So it's that whole factoring, right? This is why factoring was so important last unit. We're going to be using it. And that's what F is. So there's two ways to actually solve this. So one thing I want you to think about is, which one's better?
First one.
This one, when we actually calculate the square, or second one, when we actually factor it?
First one is your
If you like to factor, you can do that. If you like to complete the square, you can do that as well. Okay? We'll finish this lesson next class. You do have some homework though.
Are you?
So for homework,
Are you serious, Black? Are you serious, Black?
okay, for homework, all I want you to do is number 3,
8250.
ACE, number 4, BDF, number 5, BE. Can you repeat